Find the equations of both kinds of asymptotes and use them to draw a rough sketch. Okay. It's helpful if you can factor these because we're going to be looking for zero values, and that means it's easier to do that if we have pieces rather than complete expressions. Like, as far as I can tell, the numerator does not factor. So we're stuck with x squared plus x minus 7. Downstairs, we can take a 3 out of that, which would leave us with x squared minus 1. And x squared minus 1 is a difference of squares, so we can take that apart all the way to x plus 1, x minus 1. And that's about the best we can do with it. So these are two places where we probably have vertical asymptotes, at -1 and at +1. We should have a vertical asymptote at x equals -1 and at x equals +1. There's nothing in the numerator that can cancel those, so they are asymptotes. They're not point discontinuities or anything like that. 3 can't equal 0 no matter what, so that you don't get an asymptote out of that part. For horizontal asymptotes, well, just looking at the degree, do you think it's possible to get a horizontal? We have x to the 2 versus x to the 2, so yeah, it is. When the powers are evenly matched like that, you can get a horizontal asymptote. And the way you find where it is you take the highest power of x, in this case x squared, divide everything by that. And so we get f of x equals x squared divided by x squared. X divided by x squared is 1 over x minus 7 divided by x squared. All that is our numerator. And in the denominator we get 3x squared divided by x squared minus, and then we get 3 divided by x squared. I'm doing all this detail even though I know you kind of don't need it, and it's possible to eyeball these pretty quickly, but this is the standard drill. And after we've done this, because it's supposed to be the limit as x goes to infinity, we can say 1 over infinity will vanish, 7 over infinity squared will also vanish, 3 over infinity squared will vanish. What will remain of this expression will be 1 over 3. So our horizontal asymptote will be at 1/3. Okay, so horizontal asymptote at 1/3. The asymptotes alone can be enough to do a sketch of a graph, but I'd be happier having a little bit more information, so let's push forward a little bit more before we attempt a sketch. This thing isn't factorable in the numerator, but it may be solvable anyway, so let's see if we can find any x-intercepts this might have. If x squared plus x minus 7 equals 0, that would mean x is, going to the quadratic formula, minus b plus or minus root b squared minus 4 times a times c all over 2a. And let's see, I believe that comes out to 2.2 or minus 3.2. So those are the locations of our two x-intercepts. Those are good to know. The y-intercept, those are the x-intercepts. The y-intercept will happen when x equals 0, which means this thing would be 0 plus 0 minus 7 over 0 minus 3. So the y-intercept is minus 7 over minus 3, which is the same as 7/3, which is 2.3. That's another good to know. And one more thing I'm going to try to squeeze in here is a sign table, just to confirm that we know where this thing's positive and negative. That'll give us a lot of insight into how it's behaving. Not a lot of space left, but we can probably do it. So we know we have, ooh, this one's going to be detailed, because we have minus 3.2 And then we have vertical asymptotes at -1 and 1. The sign can change as you go through those. And then we also have 2.2. So this is actually going to be a doozy of a sign table. But I think we'll be glad we have it, because if there's that much going on, this thing would be a little tricky to sketch. We're going to need all this information to do a good job. There's 1, 2.2, so we're going to look in and around all those things. So our numerator is x squared plus x minus 7. This is a parabola that opens up, so I expect it to go positive, start out positive, then be negative for a bit, and then go positive again. And we know where it's going to go negative. It's between 2.2 and -3.2. So I feel pretty confident saying this is going to be positive, 0 there, negative, 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 0, and positive again. You can confirm that on a graphing calculator if you want, or plug in some values if you want to check. But we know how a parabola behaves. They normally go high to low to high if they have a positive leading coefficient. The 3 is always positive. I'm going to skip it this time. We have the factor x plus 1, which is going to be negative, negative, negative. When x is -1, this thing hits 0, and then it's positive after that. We have the factor x minus 1, which should be negative, 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 negative. At 1, it hits 0 and is positive after that. And now that we have all those pieces, we can do our grand total. Positive over 2 negatives is positive. 0 over whatever is 0. Negative over 2 negatives comes out negative. Negative over 0, undefined. We should get an asymptote there. Negative over positive times negative comes out positive. Negative over 0, undefined. Negative over 2 positives is negative. 0 over whatever is 0. And all positives comes out positive. Whew. All right, let's see if we can stitch all that together into a graph that looks like something. Here are some axes. We'll get our asymptotes down first. We have vertical asymptote at -1. Also at +1. We have a horizontal asymptote at 1/3, so if 1 would be about there, 1/3 is like that. That's probably okay. And for our actual curve, we know there's an x-intercept at 2.2, so if this is 1, there's 2, 2.2 is like there. There's an x-intercept at -3.2, so -1, -2, -3, and a bit more. Our y-intercept is 2.3. That's 1, 2, a tiny bit more. Okay, so out in the distance, the curve is going to follow these asymptotes. It's positive until we get to this intercept, so it would have to behave like this, really. It's got to stay positive, but it's also got to sneak up on that asymptote. Then we get to an x-intercept at -3.2. After that, the curve is negative. Yeah, we could have seen that coming. Negative there. There's a vertical asymptote at -1, so it's going to curve like it's scared of this line and drop. On the other side of -1, the curve is positive. So it would have to come down following the asymptote. We have a y-intercept here at 2.3. It stays positive all the way up to 1, so we can't do any crossing of the axis here. And also we have to respect this next asymptote coming up, so this would make sense. Then we have a vertical asymptote at 1. The function's undefined for a moment. When it reappears, it's negative. So it comes up like this following the asymptote. There's an x-intercept at 2.2. we have that marked in already, so we know we have to make that point. After that, the function is positive, so we have to stay above the x-axis, but also we must avoid this horizontal asymptote. So the function hooks rather sharply and does that. That should be our overall shape. We could analyze this further looking for inflection points. I don't think there are any, or intervals of increase and decrease, which would confirm what we already know here. But that's pretty good for the general shape, considering all we did to find it was asymptotes and the zeros.